it's a problem. It means that it can have cycles, long cycles. And that's it. But it is something that is under development, and this is what is written here. Questions?
About the climate change, we're just talking about the temperature. If you want to simulate by the stochastic simulation, we just simulate the temperature.
Yeah, you know, climate change, we talk about temperature because it's something that is evident and people agree. And the effect on precipitation is not clear, as I said, and also on the river flows. And therefore, you know, it depends on the type of climate models that you use. And some of them are predict a decrease of precipitation, and which is not homogeneous over the world. Others don't predict, but if you look at the data in terms of average precipitation, you don't see much differences. Okay, but the temperature is something that indeed is increasing with some fluctuations, but it's increasing. And then people debate whether it's solar activity or greenhouse gases, and it's difficult to say. And solar activity, keep in mind that is something that, again, it's not well understood. We know that there are cycles, the Milankovitch cycles in solar activity. The reason for that are not understood. And it may be a driver, but there are other potential drivers, including the greenhouse gases. So it's, you know. And keep in mind that March once was full of water, and then there was a change in climate without humans. So sometimes it is also maybe there might be changes in the magnetic field that have an effect on the climate. We know that the magnetic field is continuously changing, and it may have an effect on the climate, and it's not really clear what is the reason why in the Middle Age we had a warm period, what is the reason why under the Roman Empire there was a warmer period. It's not clear. And what is clear is that the Roman Empire, for instance, there are reconstructions, historical reconstructions that proved that indeed they had a warmer climate for most of the duration of the Roman Empire, and it was the period when they expanded. When they collapsed, there are some people who assume, or let's say propose, that fundamental driver of the collapse was changing climate, and the climate became colder, and you know, a cold climate, because a cold climate is very hostile for humans, and this is something that I don't understand why it's not considered. So basically, we emphasize the problems related to a warmer climate, which indeed may include higher risk of flooding because of increased precipitation. But we don't emphasize the fact that if we had today an increase of global temperature of 1 degree, it would be really a big problem. Because our society now is used to a warmer climate. And you know, even at the global level, -1 would really imply an advance of glaciers, very substantial, which means for mountain areas, big problems, and would be really a big, I mean, if it happened suddenly, it would be a really big problem. And then keep into account that the humans, usually in nature, they can adapt quite easily to gradual changes. What is shocking is the sudden change. The sudden change, because if we have a sudden change of temperature, like an increase, sudden change of 1 degree more, this doesn't give to the political system the time to adapt, and therefore you have wars, because you have migration, and migration because of course people massively leave from dry countries and tend to migrate to wetter countries, and this may originate wars, because massive migration may imply wars. Instead, if it happens in 200 years, the political system has time to adapt, and therefore it is less shocking. So this is why also climate scientists give much attention to tipping points, because we all know that a tipping point is indeed like sea level rise. If you have a sudden increase of 30 centimeters, it would be problematic in terms of also freshwater availability. If it is 30 centimeters in 150 years like we had, it's not really problematic. And it depends on the time scale. And, but I don't think, again, it's the survival of the planet that is at risk for climate change. The survival of the planet is at risk for its own reasons, like Marsh, they had a lot of water, and then they is not correct, but it is proved that there was much more water than on the Earth, and it disappeared because of climate change. And not only climate change, it is, the hypothesis is also a change in the magnetic field, because the magnetic field is protecting the atmosphere. If it disappears, the magnetic field, the atmosphere disappears. And therefore it's, I mean, we know that life on the Earth will not last forever. And the Earth is getting colder and colder, I mean the nucleus. And when the nucleus is still fluid, but we have the magnetic field because the nucleus is fluid and moving. You have continuing movement of iron in the nucleus, and therefore originating the magnetic field. Once the nucleus slows down, the magnetic field will disappear, and then life on the Earth will disappear. This may happen in billions of years, but it will happen. I mean, so human life and the survival of the planet is at risk for these reasons. I don't think it's a problem of risk for climate change, but indeed climate change may trigger political tensions, wars, like it's already triggering, because I think indeed that migration, climate change may be responsible in part for migration that is happening today, because typically you see that water is the driver. People don't migrate from countries that have plenty of water. Usually it doesn't happen. And it's clear, because we need water for life, and therefore, I mean, where you don't have water, it's hostile, and therefore less resources, more poverty. And if you look at the correlation between migration and water resources, it's clear, very clear. And there are exceptions, of course, because also politics, of course, but it's clear. Other questions?
I have one.
Yeah.
With this stochastic simulation, when you are taking into account the climate change, you talked about you could use the output from the climate data.
Yeah.
What output do you use?
The statistics, like there are statistics that are very influential on our problem, and the first is the average, and the second is variability. So variability typically is, in simple terms, is variance, which means standard deviations of the data. So typically, in order to, when you get a time series, the first thing that you want to compute in order to get an idea is the average. And this is why I tell you, you have to learn what is the average value of the Po River flow, for instance, but not only the Po River. If you come from a country with an important river, you cannot be a civil engineer if you don't know what is the average flow of the most important river of your country. But also the standard deviation is the second statistic that is very relevant. And then there are other statistics like memory. Memory is quantified in statistics by autocorrelation. And therefore, and it has an influence on variability. What I would suggest to take from climate models is future average and future standard deviation, and maybe future autocorrelation, but I know that climate models are not very good in predicting memory. And in simulating memory, they are not very good, and therefore I wouldn't take it. But for instance, we may make an assumption like memory is increased 20%, and which means that a drought becomes more or less longer, not 20% longer, but something similar, and which is reasonable if you I mean, it's not reasonable. The first thing that I'm going to do with this data that they will give to me, I will compute the average length of the period where summer flows are below average. So I will compute the global average, and then I will identify the periods more than 1 year when we had summer flows below average of the summer flow. And this is a drought. I mean, when you have average summer flow, this is the status quo. When you are below average in summer, you are in drought. If it lasts for 2 years, it's a bit of a problem because it means that it's a long drought. So I will compute the average length of the period below average, and I will propose which may be like 3 years, 4 years, and I will propose to increase 20%. It's not reasonable to say twice, but it's already significant. I mean, if, or we can take one extreme, so not the average period below average, but the 10% upper. And then try to design the system with this 10% upper by assuming that it becomes more likely. So there are some reasoning that must be made, and it may look like we are making a trial and error procedure, but it's not like that, because in making this evaluation, in saying plus 20 or minus something, we make a empirical evaluation from the point of view of an engineer. So the people from here with whom I spoke, they are engineers, and they didn't say 100% because they know that it's unlikely. They said minus 20 because this is something reasonable, and in fact they said yes, this is fine, and probably agrees a little with the output from climate models. They will not say temperature. They will not say. The most pessimistic climate models in terms of temperature, they say by 2100 temperature may be 3-4 degrees above pre-industrial level. Now we are at 1. And they say, in the Paris Agreement, they want to limit to +2. And this is the target for 2100. Because why they say we want to stay into +2? Because the most pessimistic climate models say +5. But there are some climate models which say that if we don't take any action, it will be +3. And therefore, they make an average and they say, okay, let's stick on +2. I mean, they are not saying that temperature will increase 10 degrees. And no model is predicting big changes. There is the feeling that there might be tipping points. Tipping points for the ice cap, so sea level rise. It's unlikely that we get a tipping point for temperature. Unlikely that we get a sudden increase to, nobody says that. But many people speak about possible melting of the ice cap, which already happened in the past. So it's possible, indeed it's possible. The timing is not clear. Okay, thank you.